Hello guys, this is Jimmy. So today we're going to talk about one extraction lines that one of my clients bought from China. So this video was recorded about 3 weeks ago, and at that time I was speaking in Mandarin. So I have to add another soundtrack that was speaking in US in English. Just explain to everyone about how this production line work. So I just get a call from my previous clients, and they said they need some consultation and maybe adding some equipment to their current production facility because this current production line is not working so well. This production line was designed for about extracting about 500 pounds of hemp each day. They have they have other two production lines in the house. So let's take a look of the production line. So there are two sets of lines. So this is one of them, and they're using co-ethanol extraction, and they have a fallen film evaporator behind it. They have filtrations, all the pipelines, all the chiller and heaters are included. So this production line, one of them costs about 160,000. So two lines cost about $320,000. So this first tank on the left is the co-ethanol tank. So they have a chiller in the next room that keep chilling down the ethanol in this storage tank. This storage tank is jacketed, so the coolants will run through the tank so that the whole tank will be chilled down to -30, -50 degrees Celsius. So in the center, we have a extraction tank. So the co-ethanol will be piped into the extraction tank, mixing with the hemp biomass in it. And as we can see from the bottom, this is the unloading area for this hemp extraction tank. And they have what they call a blade or a stir inside that mixing up the hemp and ethanol. You can see over here there's blades right inside, and on the bottom they have filtration, so make sure that no biomass will go into the later stage. So they have a dual stage filtration. This is the first stage. This is the normal filter that we used in industry. They put down about a 200 micron, 150 micron filter bag in it for first stage filtrations. And we have a buffer tank, or we call a temporary storage tank in the middle. So all the ethanol, all the filtered stuff will go inside, and then there will be a second stage filtration on the right. So you can also take a sample out of it on the using the valve on the bottom. And this is the second stage filtration. So on this stage, people will use about 20 micron to 30 micron or 50 micron filter paper in it, and then they will keep pumping into the next stage. This one will be a big storage tank for the ethanol mixing with the CBD. So let's take a look at let's using the other side's tank for example, because they have all the nameplate facing us. It's easier for explanation. So these two tanks are are the supporting system for the what they call the water ring vacuum pump. So the water ring vacuum pump is right here. So this is very standard vacuum pump. They consume water and form a ring to seal and use it as a vacuum pump. Right here we have a recovered liquid storage tank. So in this production line, the recovered liquid will be liquid ethanol. So all the ethanol that evaporated during the heat exchange will be condensed by this heat exchanger and fall down to the storage tank. So on our left, we have a set of what we call is a falling film evaporator. So this falling film evaporator claimed it can recover about 500 liters of ethanol, which will be around 130 gallons of ethanol per hour. So basically, all the filtered liquids will come inside, and all the ethanol that have low boiling temperature will boil off and become vapor and transfer into the heat exchange and condense in the storage tank. And they said it can do 130 gallons, but I don't think it can do it because based on the size, it probably can only do 300 per hour. So all the liquids that have a higher boiling temperature will go into this tank, and this tank will keep concentrating the liquids into a denser form. So on the falling film evaporator will recycle about 90% of ethanol, and this what we call a bowl concentration tank will keep concentrating the liquids by heating up with steams, and it will recycle the last bits of the ethanol out of our CBD crude oil. And we have also collections for evaporating ethanol in this stage as well. They are liquid gas separator, and this is the condenser for the ethanol vapor as well. So this system, from my point of view, has some disadvantage. The design is not so good. The first of all is that this whole system only have one vacuum pump, which is not right at all, because we have extraction stage, we have filtration, and we have ethanol recovery stage. So it should at least have 2 vacuum pump or 3 vacuum pump in the system. So right now I only have 1, which make no sense because different stage require different vacuum depths. For example, in the extraction stage, you might need less vacuum, but in the filtration, you need more vacuum to facilitate the filtrations. And in the ethanol evaporation stage, you need also a lot of vacuum so that the recovery rates will be much faster. And also, there's another disadvantage, another design fault would be this system might not be designed for hemp extraction, or what we call it's not designed for low temperature hemp extraction. So Asian, they have hemp extraction operation as well in the Southeast Asia, and they're using a different methodology. They're using what we call a high pressure, high temperature extraction. So this tank was designed for high pressure and high temperature. It's not designed for low temperature. So at low temperature, this area, the ring will be frozen, and they have a hard time to getting the liquids from the tank into these filters. So based on what operator says, every time they use this tank, this area will be clogged, and then they will open up and create a mess in this production line. Because this production line was not designed for low temperature, so they said the viscosity of the liquids at the low temperature is quite different from high temperature, and they don't use high pressure in this stage, so they're much less forced to force the liquids out of the tank. Also, as we can see in this video, it looks like it will have a hard time for loading and unloading the hemp into this tank. You need to climb up very high and load it from the top, and it's hard to collect as well. So that's why I suggest to use centrifuge as extraction methods. So as you can see, they have a centrifuge in place to replace the extraction tank. They're not using extraction tank right now. Also, another not so considering design is that the filtration is working not so well. And the first stage is fine, but the second stage filtration, this one is a disc filter, so they can place a very fine filter paper in it. But the problem is the filtration speed is so slow because the surface of the filtration area is too small. There's only this much. The filter paper will place underneath these iron plates. So our clients come up with a much smarter design, which they custom build a filter table right here. So they pump the liquids into this table and they place the filtration on the bottom of the table, and all of them will be filtered much faster because the surface is much bigger. So right now I know why they have a buffer tank in between, because the first stage filtration speed is much faster than the second stage, so that in order for all the liquids pump out from the extraction tank and not blocking them for the second loads, they filter the first stage very fast, and all the liquids will go into the storage tank so that they can unload the biomass in the first stage and adding new material in it. And then they pump from the storage tank to the very slow filtration on the second stage, and then they got filtered out and go to the ethanol recovery. So in my point of view, that for this production line, they need at least 3 stages of filtration. So the first stage would be 150 micron or 200 micron, and second stage would be around 80 micron. Third stage would be around 20 micron. The micron sizes will be changed based on the biomass. I mean, different material, they usually some people grind the powder into much finer, so that they need a much better filtration, and some people don't grind it that much, so they don't need that much filtration in the systems. So this two small storage tank confused me at the beginning. So after I take a further look, and I know that this two filtration tank is the supporting tank for the liquid ring vacuum pump. One is that filled with water and keep pumping the water into the vacuum pump, and the other one condense the water vapor that come out from the vacuum pump. In my point of view, that one liquid ring vacuum pump is not powerful enough to power the whole production line. So you need at least 3 good vacuum pump. Liquid ring vacuum pump is very robust, and but the vacuum depth is not so good. So what I recommend is that you could use liquid ring vacuum pump in the very high solvents, in the environments that they have a lot of solvent that evaporating into the vacuum pump. But you could use a better vacuum pump for other areas, such as the extraction. The manufacturer also do some good design for this production line as well, and one of them is that the cooling capacity for this production line is good enough. So they put a storage tank, they put a chiller right next to this production line in this room right here. And this chiller was marked as 90 kilowatts in cooling capacity, which is well enough for chilling that much ethanol into -50 or even lower. I asked about how the performances of this chiller, and my client says this chiller can chill down the ethanol into -80 C. Oh, also there's another not so well designed right here. So you see the heat exchanger right there. So that one was cooled by the water tower that is located next door, and the water tower can only cool down the temperature down to like 15 C, which is the water temperature of your local water source. It cannot reach lower than that, but sometimes for chilling down the ethanol, the lower the better. If the temperature can reach down to 5 degrees Celsius, then the recovery rates of the ethanol will be improved significantly. So what I would suggest that you should get a 2-stage heat exchanger. So you put another heat exchanger down there that supplied by the chill water water chiller. And so that would be all my comments and suggestions in regard to this hemp extraction production lines. The manufacturer says that this production line can do about 500 pounds per day, but right now the production is suspended because this extraction tank is not working nice, and right now I'm sourcing two big centrifuge for these two production line for my clients. And after centrifuge is in place, just hook up the just hook up the chillers, and everything should be good to go. So I'm going to talk about further like distillation in the next episode.